To understand the vapor compression cycle, we must first understand the following concepts: sensible heat, latent heat, and specific heat capacity. The heat measurement of the SI unit of heat is called the joule. In refrigeration and air conditioning systems, the unit of heat used is the kilojoule, which is equivalent to 1000 joules. The specific heat capacity of a substance is the amount of heat that must be added or released to change the temperature of 1 kilogram of the substance by 1 degree Kelvin. Specific heat capacity is measured in kilojoules per kilogram Kelvin. Each material has a different specific heat capacity. Ice has a specific heat capacity of 2.11 kilojoules per kilogram Kelvin. The specific heat required to cause a temperature change in substances varies with the type and amount of substance. Different substances require different amounts of heat per unit mass to affect these changes of temperature above and below freezing points. The amount of heat required to raise the temperature of 1 kilogram of water by 1 Kelvin is equal to 4.187 kilojoules. The amount of heat removed to lower the temperature of 1 kilogram of water by 1 Kelvin is also 4.187 kilojoules. The amount of heat required to raise the temperature of 1 kilogram of ice by 1 Kelvin is equal to 2.11 kilojoules. Sensible heat is defined as heat which causes a change in the temperature of a substance. The term sensible is applied to this particular heat because the changes in temperature can be detected with the sense of touch and can be measured with a thermometer. For example, water can be heated from 25 degrees Celsius to 50 degrees Celsius without changing state. In a split system, the sensible heat change is seen when the refrigerant is cooled or heated by the ambient air temperature. For example, in an R410A system, if the refrigerant temperature entering the indoor unit is 2 degrees Celsius and the ambient air being pulled over the coils by the fan is 27 degrees Celsius, the refrigerant will absorb the heat, causing the refrigerant to change temperature to 8 degrees Celsius. This is an example of sensible heat. This will also occur on the outdoor unit of the split system. The refrigerant, which leaves the compressor at a high temperature, will change temperature as the ambient air is pulled over the coils, rejecting the heat in the refrigerant. For example, in an R410A system, the refrigerant leaves the compressor at 60 degrees Celsius, and if the ambient air is 38 degrees Celsius and flows over the coils, the temperature of the refrigerant will reduce to 50 degrees Celsius as the heat is rejected. The change in temperature is a sensible heat change.